And our strategy is breadth first. In earlier example, that is depth first search, we were going for every time from S, we are going towards the depth, that is down. We are going down and down, down and down, right? This is similar. If I want to give you real life examples, like if suppose I want to find water content on a ground. Actually, this is not computerized problem, but logic of the search is same, because this is blind, right? Many of us are not knowing where exactly is the water. Actually, there are people, they show you, or there are even satellite images, but everything is again some approximation, some informed search is there. But suppose we are finding water without having any such information, so what we will do? So first of all, we'll stand on a particular point and dig towards maximum and check that whether I am getting water or not. If not, again I will try another point in the same area. So first node I went to the depth and check whether I have got water or not. Then I go to second point. Again tried for. And this I will do in my land till I am getting water. So this is what depth first search. So water point is the goal point. That is goal node. Then how do you proceed? When you start digging, you see that a particular rock is there, whether you find some traces of the water, a certain structure is there, right? This is how you dig the well also. Another aspect is now breadth first search. Now same water we are searching, same land is there. Now we will take samples, right? Now we will take as many as possible holes. We will not go in depth, and we will check that where on near surface we are getting water. So we expand on the breadth, that is one width. In earlier case, we have specific point, we go to the depth and check water is there. In second part, we are digging many holes and checking that whether we are getting water or not. So breadth first is that now we are expanding horizontally, right? We are expanding horizontally. Now S, D, E, D. Earlier we were what we were doing? S, D, and E, H, E, R, F, G, A. This is how we were going. This is how we were going in earlier cases. So we were going from like D, E, R, F, C, A, depth. Now we will go like S, D, E, P, B, C, E, H, R, Q, and again likewise. So this will be horizontal. This will be horizontal. So layer by layer search, branch by branch search, right? Or they are said as the tires of the search. And here now the list will be in the FIFO and Q structure will be there. List will be FIFO and Q structure will be there. Now, what is difference over here? How you generate successes. How you generate successes and how you go back and take new successor or new node over there. Now same example we are solving with breadth first. Now remember, A is the first node. So A is taken in the list. Now B and C are the next nodes. So B and C are generated and they are placed in the fringe. Now see that I will be taking C as a first. I am not taking D. If it is depth first search, then it will be A, B, D, C, G. Now it will be like A, B, then C, then D, and then E. Are you understanding? If it is depth first search, it will be A, B, D, C, G. Now A, and already two children are there, B and C, they must be completed. they must be completed. So A, B, C, D, E, D, G. See, this will be like this horizontal. It is like horizontal scanning, right? So now in French, B has gone out, its children added, but after C. If this is depth first search, then it will be DEC. If it is breadth first search, then C comes first and D is afterwards. See, this is what difference between stack and queue. Now we have visited C. Now we have to again add DG. So DE first added after expanding B and then DG. So see, all horizontal we are completing. That is what breadth. DEDG. And again now we are expanding everything, correct? So now we are at D is gone out and that CF is added here. E comes first because D has gone. E comes first, D comes second, G comes third, and C and F comes at last. Now next point, E goes out, but E was not having any children because it was leap node. So this is going out, but no addition. So list is appended. So DG will be as it is and CF will be there. No expansion in this part because there were no expansion part here. So you were not having any kids to the E. No children was there. So this is just entered in previous state. It was at top, right? So it is removed and next two are here D, G, C, F. Now you are at D, but D is now expanded as a BF. So BF will be added last because CF is already there, right? Now G is already there, so we are at D. So G is already there, and then C, F, B, E are there. But remember, G is my goal, and my search is now completed. So I have to write all this path, right? A, B, C, D, E, D, G. This is what my path for this search. Once again, if you are not understanding, I'll come back. See that we have to search horizontally. So A is taken, then A is now expanded to B and C. So B is expanded to C and F. Now
Yes, sir.
Yes, sir.
so I was rediscussing. So A is there, then we are having B and C. So A is expanded to B and C. Now we have to scan horizontally. So B and C, next part will be B is expanded, but C is still unvisited. So C keep at top of the list. Then D and E will be added. Now C will be going out. D was already there. Now C is having new two children, that is DG. They are also added. Next part, D is going out, already gone out because we have got these two. So E will be on the top stack. On the top of the stack, E will be there. Now E will be going out. But in this turn, E is not having any children. So nothing is added to the list of nodes. At that part, now we are removing E and again come back to the search. After E, I will go to this D in this branch. Now this D we have to expand. So BF will be added, right? And again G will be as it is or CF as it is. And finally, when we reach at G horizontally will be the goal. So our path is A, B, C, D, E, D, G. So this is answer of my this problem. Now BFS is complete problem. It is optimal. It gives solution, right? But optimality is having some cost over there, but it is admissible. That means it gives the solution. This is simply because we scan every node. We scan every node. Nothing is skipping. So I am going to the each and every node I am visiting. So my solution is guaranteed. So I am checking every node, right? But many times, if nodes are large, then cost will be very high. The time space formula will be here. That is O. It is denoted as O B into D, right? D is the depth and B is the number of branch or branching factor. This is what time and space. For now, BFS, time and space is same because see that it is scanning, it is taking everything. So time is same and space is same. DFS, space will be different and time will be different. In DFS, you are not visiting all the branches. We are selecting deepest branch first, or we are selecting logically goal side branch first, and we dig to the that branch. Okay. Now this is what some example text snapshot. So this is A expanded as a B and C, and then C is visited, and D is there, and finally your goal node is F. This is graph actually. This is not tree. We are resolving graph.